Hello everyone. In this video, we are going to solve the problem number 1.75 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. In the arrangement shown in figure 1.18, so this is figure 1.18, in which we have the pulley and block system where this ball mass is m1 and the rod mass is m2, and in the problem it is given that the mass of ball m1 is equal to eta times m2. Okay, and the friction between the pulleys and the thread are negligible, and the lower end is actually aligned to the end part of this rod right now, and it is asking that when the rod will move, let us say in the downward direction, and m1 will move in the upward direction, then when both the meets at the one point and it will aligned with the top point of this rod, then what is the time taken to move from mass m1 from this point to this particular point. So let us first draw the free body diagram of mass m2. So this is the rod of mass m2. So there will be the gravitational force of m2g in the downward direction, and in the upward direction, let us say the tension at each point on this thread is T. The moment I said at each point the tension is same, and that is T, because there is no friction between the pulley and the thread. So let us assume that the tension force is T, and let us also assume that this particular rod is moving in the downward direction with the acceleration of A. So if we balance the forces, then we can write m2g minus t is equal to m2 into A. So this is our first equation. Let us draw the free body diagram of this particular pulley. So this is the pulley, and in the bottom, in the downward direction, we have like two tension forces because of these threads, and the tension forces are T and T. And let us assume that the tension force at each point on this particular thread is T1, and again I am able to say that at each point the tension force is T1 because there is no friction between the pulley and this particular thread. So in the upward direction we will have the tension force of T1, and it is given that the mass of these pulleys are negligible. So let us assume that the mass of pulley is equal to 0. And if we write the force equation for this pulley, then we can write T1 minus 2T is equal to mass of pulley into acceleration, and this particular term is 0. So from here we can write that T1 is equal to 2T, and this particular acceleration may not be A, it may be, let us say, A dash. Now let us draw the free body diagram of mass m1. So this is mass m1. We will have the gravitational force of m1g in the downward direction, and if we replace m1 with eta times m2, then it will become eta times m2 into g, and in the upward direction we will have the T1 tension force because we have earlier mentioned that at each point on this particular thread the tension force is T1, and this particular ball will move in the upward direction, let us say with acceleration of A1. So if we write the force equation, then we can write T1 minus eta times m2g is equal to eta times m2 into acceleration. So this is the third equation that we are having. And this is the second equation. So if we carefully look at the first, second and third equation, In the first equation, we are having the variables of t and a. In the second expression, we have the variable of t1, and in the third equation, we are having the variable of a1. So basically, if we look at this variables, so basically we are having four variables but only three equations, and with three equations we would not be able to determine four variables. So therefore we need to have one more equation, that is called the constraint equation. Constraint equation. To find out this particular equation, let us consider the entire system. And if we consider the entire system, then the tension force will become the internal forces. So if we consider entire system, then tension force will be the internal forces. And we know that work done by all the internal forces is equal to 0. Okay, so basically if we see here, then work done by tension force on mass m1 and work done by tension force on mass m2, that should be equal to 0. And if we carefully look at here, the mass m2 is basically this particular rod, and the tension force here is T, and it is going in the downward direction with the acceleration of a. And for mass m2 or for mass m1, basically we are having the tension force in the upward direction, that is T1, and acceleration is also in the upward direction, that is a1. Now let us assume that this, because of these tension forces, it is going in the downward direction by the distance of x, and this particular body is going in the upward direction with the displacement of x1. So if we write the work done by the tension force on the m1 mass, that is this one, and the work done by tension force on mass m2, then basically this is T1 into x1. Both are going in the same direction. Both the tension forces and the displacement are in the same direction. But here if you see, both the tension forces and the displacement both are in the opposite direction. So we will have the tension force into x is equal to 0. And if we differentiate once, then the displacement will become the velocity. So we can write T1 into V1 minus T into V, that is equal to 0. And if we differentiate it again, the velocity will become acceleration. So that is T1 into A1 minus T into A, that is equal to 0. So basically we have from here T1 into A1 is equal to T times A. And from the second equation we know T1 is equal to 2T. So we can write 2T into A1 is equal to T times A. So T will get cancelled, and from here we can get A1 is equal to A by 2. So this is the acceleration we got. Now if we rewrite the first equation, that is m2g minus t, m2g minus t is equal to m2 times a, and third equation is t1 minus eta times m2g is equal to eta times m2 into a, and we know T1 is equal to 2T. So basically this equation will become 2T minus eta times m2g is equal to eta times m2 into a1 is a by 2. So let us say this is our fourth equation and this is our fifth equation. Now we want to eliminate tension force, so let us multiply fourth equation by 2. So we will get 2 times m2g minus 2t is equal to 2 times m2a, and this equation will become 2t minus eta times m2g is equal to eta times m2 into a by 2. So if we add these two equations, we will get 2 minus eta times m2g is equal to m2 into a times 2 plus eta by 2. So from here we can get acceleration is equal to 2 minus eta times g whole divided by 2 plus eta by 2. If we further simplified, we will get 2 times 2 minus eta into g whole divided by 4 plus eta. So this is the value of acceleration we have. And if we determine a1 is equal to a by 2. A by 2, that is equal to 2 minus eta times g whole divided by 4 plus eta. Okay, now it is asking to find the time taken to reach the ball 1 from this particular point to this particular point where it is aligned with the top point of this rod. So as the m2 will move in the downward direction and m1 will move in the upward direction, let us say somewhere between these 2 points they will meet the end point of this rod and the ball 1. So here we need to apply the relative motion concept. So let us say m2 is fixed. If m2 is fixed, then mass m1 was moving in the upward direction with the acceleration of a1, that is a by 2, and the rod was moving in the downward direction with the acceleration of a. So if we stop this, then this particular mass m1 will move with the acceleration of a plus a by 2, that is 3a by 2, because we know the acceleration of body 1 with respect to 2 is equal to acceleration of body 1 minus acceleration of body 2, and acceleration of body 1 is a by 2 in the upward direction, and minus, if we write the acceleration of body 2 in the downward direction, so it will be minus of a because that is in the downward direction. So basically the acceleration of a with respect to 2 will be 3a by 2. Okay, so the overall acceleration of the mass m1 with respect to mass m2 is 3a by 2, and we know that the distance traveled is equal to half into a into t square. So half is equal, s is basically the L, that is 100 centimeter is equal to 0.1 meter is equal to half into a is basically relative acceleration here, that is 3a by 2 into t square. So from here we can determine t is equal to 0.4 into 0.4 divided by 3 times a under root. So this is the time taken by ball 1 to move from the bottommost point to the uppermost point of the rod m2. Okay, I hope this is clear. A we have already found out here, that is this particular equations. So if we can just substitute here, so the value of t, we will get t is equal to 0.4 times 3, and a is 2 times 2 minus eta into g, so basically 2 times 2 minus eta into g, and here whole divided by 4 plus eta. So this is the final expression we have. I hope the solution is clear. Thank you.